I was using FreeCAD a little bit, but I found it was kind of hard for me to get my head around the different workbenches and so forth. So this environment is sort of one environment that you go into, and it does have a few modes to it, but overall I found it pretty easy to wrap your head around. Plus, if you ever want YouTube videos and stuff like that that people have made to explain specific features, there's a million of them out there for this particular system, for Fusion360. So these are some little devices and so forth that have been all made in Fusion360 and used on assorted robots. What we're going to do is, this is a, can you see that, Bill? This is a time of flight sensor that's very popular for measuring things out in front of the robot. Did you get that?
Yeah.
Okay, great. So we're going to make the little bracket for the time of flight sensor. And what I wanted to explain first, though, is you see, do we see it? Yes, we do. And of course, I looked around for my laser pointer, couldn't find it. So this is the environment you basically have. We're going to be playing videos and not actually trying to do it, so that way I don't get stuck on stuff. There'll be 3 videos. And the main concepts that it has are similar to FreeCAD, where you end up with a 2-dimensional sort of a grid piece of paper in front of you, and you put circles and rectangles and things like that, different angles and so forth, measure your lines and everything. That's called a sketch. And you do that, and then you pull things out to make them grow into 3D space. So you make a flat drawing, and you pull things out of it, okay? So here we go. I'm going to have to talk over this. I'm going to be staring at this and then trying to keep up with what I was doing at the time. I didn't record audio for this. Okay. So this is the main environment. In the upper right, oh, I think I can use my mouse. Ha ha! There's my laser printer. This is the design right here. Little piece of 3x3 notepad. Make a design. Have something in your head rather than just wing it. Because if you wing it, you're gonna get in trouble. So that was what we're going to make. I flashed it on real quick to say, do that first on paper, and then come into here. You go into the sketch, and this is where we create a sketch. And in this case, I have X, Y, and Z in your upper right. And I say I'm going to look straight down on the surface, as if I was printing it. I'm going to be looking from this direction. So you have a grid, you set snap to this sort of thing, which is common for a CAD system, so you don't get lost. And I usually like to put a couple construction lines down first. So what I'll do is I'll take a line and maybe a couple of key dimensions that I wanted to use, and rather than kind of find the spot, you can just type it in. You can say 17 enter, boom. It's much easier than trying to find the actual spot. So I do a couple of those construction lines here. And we're going to start making now the outline of the back surface of the little gizmo that we're making. So I ended up making each of these lines into a construction line as a right click and saying, hey, I want it to be a construction line and not a real line. That's kind of what's happening right there. Now we're going to start making an outline of the overall base of the little bracket. I'm having some trouble landing on what's happening here is I'm having trouble landing on that point, so I guess you can even screw up in a pre-recorded demo, can't you? Anyway, here we're going over there, we're going to the other side, and now you see it's like you're on a piece of paper and you're just making a drawing. And then after we're done with this, we're going to put little shapes on it, because the device itself has a couple of standoffs that have holes for screws to screw in this little board that was in the original one. So that's the overall goal. I'm making another line on the side because I'm going to want later to take and make a right angle. So I'm going to take that piece we just drew on the edge, right there, and later I'm going to pull it up to be a right angle mounting bracket And this gives you a feel for, I go and find little places and I say, oh, I want a 6mm diameter circle of plastic here. So I put in 6mm, enter, and then I am using a free version of a video recorder, so I made the demo into 3 parts. So we're getting close to the point where I'm going to end the first video, which is just a flat sketch. Then we're going to go into the 3D part of the demonstration, which is where you grab things and you pull them out of the surface, or extrude. That's the word there. So now we're making the other little hole. And now we have another mounting hole that we're just putting off here. So I'm kind of trying to give you a feel of, in real time, what you would do to make some little bracket or something like that. Which actually, I'm going to actually use these on an espresso bot, which I've had in here before. And it's currently a hot glued kind of configuration. So it'll be a little nicer with these things. Okay, so that's the first part, and it's going to probably time out in just a second here. And we'll go to the, there it goes. And we're going to go to the second part now. Okay, here, and part 2. And you got to click this, otherwise it just sits there. All right, so this is where we left off on the last piece. And what I ended up realizing is I hadn't made the little holes that I'm going to eventually be screwing a self-tapping screw into. So there again, that's the original design. Pretty fast, but you get the idea. You sketch something first before you go to this thing. Otherwise, you're going to waste a lot of time. It has redo. It has all these abilities to save different versions as you're going along. In this demo, I'm just plowing through it, basically. So I'm still on the sketch, which is the piece of engineering paper, and I'm making little holes that will be the places where I'll be putting in self-tapping screws, and those are like 2.2mm across. And then we're going to get to the fun part. That's where you start pulling things out of the surfaces, and it really comes into a 3D space when you start extruding. And you end up selecting little areas and then saying extrude, and then you just kind of pull them out. It's pretty cool, actually. Even if you weren't making anything, it's fun to dork with it. It's quite fun. So now what I did is I highlighted all the areas that I want to grab and pull out as the main flat surface. So we haven't put any raised parts in for the screw holes or anything yet, but we've just put in, now I'm doing the L-shaped. I'm going to make this 12mm high raised part here. It would have been a funner demo if I actually had this at an angle while I was doing this, because then you guys could like say, ooh, ah, look, it's growing. You know, we'll see it in a little bit though. I'll rotate it around. So what I'm doing is I'm raising up the screw hole to the distance I want off of the combined distance of the plate plus 3mm. I could have actually selected both of them and done them at the same time and just extruded them both at the same time. I think we're about ready to, I wanted to show that when you do this and you extrude something, you lose the flat sketch that you had originally. So I had to go over to the right and highlight it to make that original piece of paper, if you will, show up from before. But anytime you do anything in these packages, if you want to make some hole, which we're going to do in a moment on the far end, there, see there's the little guy rotating around. If we want to make something on this surface there, we have to make that into a sketch. So, I mean, you have to make that into a little piece of scratch paper, and now it flips it so you're looking at it straight on. And I'm going to put a little hole in the end of this, and this is kind of fun because we'll put a circle on there, and then we're going to draw that circle through the solid to drill a hole, basically. And so it's similar to what you've seen before with the OpenSCAD, where you do a subtractive operation, where you're really subtracting one cylinder from a plane. Okay, now it's going to, I put it at a little bit of an angle, and you can, this is the only part you're going to actually be able to see something going on. I extrude and I go back into the piece, and you see how it shows it in red? It means it's cutting into that existing surface. So once I do that, I'll rotate it, and you can see that there's a little hole in there, okay? So that pretty much completes the second part of this, which is showing how to make a solid thing, a solid model in Fusion360. The last video is, now what am I on about? Oh, I'm just getting excited about twisting it around again to show you. Okay. But anyway, you can rotate it and stuff and take a look at different angles and so forth. And this one will end pretty quickly. Oh, no, I'm doing another fun thing. Okay, cool. So what I'm doing here is I'm using an operation on the corners to fill it in the corner and make it nice and rounded. So you can make rounded edges, you can do chamfers, angles, you can make angles at any, you can take a circle and make a kind of a hole for, like, say a screw, you know, a 60-degree hole for a screw. You can do all kinds of these little cute operations, some of them required and some of them just for aesthetic, you know, reasons. Okay, so now I think we're done with this thing. And that was the longest of each of the demos. The next one's really, really short. We're going to show you the process it takes to export it out to a 3D printer package that's called a slicer, which basically takes your model and forms all the commands it takes to talk to a 3D printer and tell the printer to start laying down goop on each of the layers. And that's why they call it a slicer, because the printers are, my printer just extrudes a piece of filament, you know, all around, like most cheap printers are like that. I can't afford an SLS. Okay, so this will go kind of fast. I'm not going to get into 3D printing and all that. I just wanted to show the process that happens here. We're going to take this part, which has now been laid out and in 3D, and we're going to go into their make menu and say, oh, I want to do a 3D print. I'm not doing this hooked up to my printer in this demo. I'm just going to export it to a little file. So I unclick a little box, but then I click on the part that I want to export as, and this will come out as an STL file, which Ralph had mentioned. It's a pretty common file type used to model and move your file to somebody else who can then make it. You can do this right now when I've got this file, send off to Shapeways, send off to any number of vendors, Voodoo Manufacturing, and get them to make it and send it back to you. So you don't need a printer. The first couple designs I did, I just sent them out and they came back. So this is the slicer. I'm showing here that you can go into this and load in that thing that we just created in Fusion360, which is a file, an STL file. And we're going to pull it in, and boom, there it is. It looks like it did in the CAD package. No big surprise there, by the way. And then you set up the parameters. I loaded in some default parameters, and I say export it to what's called a G-code file. And after that, you take your G-code file and send it to your printer, and you make one of these. And that's it. So you can come up later and see some of these goofy little things I've made and stuff. And if you want to ask any questions, I guess we'll take one or two, because we're going to have a panel, actually. Yes?
Do any of these have a gear simulators or gear design built in?
I've done some gears before, too. I haven't done it in Fusion360.
No, but I mean,
don't know.
You design one yourself, but there's
actually, I did it in FreeCAD.
Yeah, I have a package called Bobcat. It didn't have a gear design. And you just put parameters in, number of teeth, dimensions, and it makes it for you.
There are things like that. I don't have that on this right now. I did it in FreeCAD, actually, as some kind of plugin or something. Yeah.
Yeah, I've used the parametric gear generator and opened SCAD, and then pulled that into Fusion360, and it works just fine.
Yeah, see now, so you made an STL file, correct?
Yeah.
Yeah, so you can take these tools and mix and match them. You make your one tool's really good at making gears, boom, you go over and use it, and then you pop it into your other tool, and this supports, Fusion360 supports assemblies and all that too. But I haven't gone there yet, and it's just way too involved with the thing. So I think I'm all set. Anybody else? One more, and then we're going to go to our panel. Okay, thank you very much.